One of the most confusing things about percentage increase and decrease is actually the way that questions are worded. For example, if someone asks you to increase something by 50%, what they mean is take 50% of what you already have and then add it on. Now, what you already have is 100% of whatever it is. So if you add another 50%, then this is the same thing as saying, find 150% of what you have, okay? So if you're increasing by 50%, you have to remember that you're adding it to the 100% of whatever you already have to find 150% of something. When you're going to decrease something by a certain amount, let's say we're going to decrease something by 30%, there's two ways you can do that. You can find what 30% of the thing is, and then you can subtract it from what you started with. But the simpler way is to say, well, I had 100% of it in the beginning, and if I decreased it by 30%, what percentage do I have left? And it's quite easy to say this is the same as doing 100% minus 30%, which is finding 70%. Now, why is that easier? Well, taking a simple number away from 100 is something that I can quickly and easily do in my head. So I can say if I'm decreasing by 30%, I just want to find 70% of that thing. And then I've only got one job. And once I've found 70% of a number, that'll be the answer. Whereas this is a two-step process. Finding 30% might be an awkward sort of number, which if you're working with money or something like that, could be sort of complicated. So the subtraction that you have to do at the end to take it away might be harder than this nice easy subtraction here, which I can easily do in my head. So it's probably going to be more efficient to find 70% of the amount if you're decreasing by 30%. So let's have a look at an example to see how to do it. If we want to decrease $15 by 60%, then basically we can rewrite the question and we want to find 40%. Now, why is that? Because we had 100%, we had all of our $15, 60% was taken away, so we only now have 40% of $15. Now, there are actually lots of ways that you can do this. You can choose your favourite. One way would be to say 40%, that's 40 100ths, of is times, and then I write my $15 here. Now, if I just write 15, then my answer will be in dollars. So if it's a decimal, the decimal point will just be where the dollars and cents get split up. You can easily simplify this fraction, divide by 10, divide by 10, half the top, half the bottom, and we've got 2/5 of 15. Now I know 1/5 of 15 is 3, so 2/5 of 15 must be 6. I thought that through in my head. Another way I could have done it is to do the numerator times the numerator, top times top, 2/15s, that's 30, and then divide by 5. 30 divided by 5, also 6. So lots of things you could do. You could also cancel here the 15 and the 5, divide by 5, divide by 3. Now I've just got 2 3s, a 6. So using this method with a fraction for the 40%, there's lots of ways you can get to your answer nice and easily. So the answer here is $6. Other ways you could have done that, well, it would be fine to say 40% is 0.4, and that's of 15. Okay, now that's exactly the same as finding 4 divided by 10, because 0.4 is just 4 divided by 10. I've moved the decimal back one place, multiplied by 15. Now I can change the order up here and say, let's do the 4 15s first, and then divide by 10. 4 lots of 15 is 60. 60 divided by 10 is 6. Okay, lots of ways to do it.